Hi, hello, good morning students. Today we are going to discuss about semiconductors. Okay. So in this semiconductors, first let us discuss about basic things of semiconductors. First let us discuss about intrinsic semiconductors. So here we observe any intrinsic semiconductor. So intrinsic semiconductor can be called as a pure materials which are known as intrinsic semiconductors. For example, let us consider germanium or silicon. So these two are considered as best pure materials, germanium or silicon. Example, germanium or silicon. So here, germanium or silicon can be considered as pure materials. Now let us consider any one of the material. Let us consider germanium or silicon. First, let us consider any silicon material. So if you consider silicon materials, so materials are nothing but the materials which are here. The materials are defined as the atoms which are aligned in a regular form. That is, all the atoms are aligned in a perfect manner. Then only all the metals are formed. So here, if you consider, so silicon material. So the material, the material is one atom. Every atom will consist of four valence electrons. So here, you have considered silicon material, and in the silicon material, you have considered one atom. So if you consider one atom, so there consists of four electrons. So here these four electrons, in order to maintain stability, so that's why they're making bonding with the neighboring silicon atom. Neighboring silicon atom. So here all the metals, all the atoms will be in this form. So So this electron, in order to maintain stability, is making the bonding with the neighboring atom. So in this way, all the electrons which are available in the material, they are making the bonding with the neighboring atom. So in this order, if we observe, all the electrons making bonding with the neighboring atom. So this is the structure of germanium or silicon structure. So all the structure will be happen only at the 0 Kelvin temperature. And when the temperature is at 0 Kelvin, so we can observe this kind of structure. So at 0 Kelvin temperature, all the electrons are so which are bonding with each and every atom. So all the valence electrons are bonding with the neighboring atoms at a 0 Kelvin temperature. The silicon metal is going to act as an insulator because no free electron exists. So all the electrons are bonded or all the electrons are attached to each and every atom. So since no free electrons exist in the silicon material, so that's why at 0 Kelvin temperature, the silicon material is going to act as an insulator. The same way, if you observe in the case of energy bands. So in the energy bands, there exists of two energy bands. That is, one is a valence band and another one is a conduction band. So here there exists of two energy bands. One is valence band, which is located at the lower state, and another one is a conduction band, which is located at the higher state. So depends upon the material, the energy bands. These two energy bands depends upon the energy of the material. So there exists of two energy bands. In between valence band and conduction band, so there is a small gap formed in between a valence band and conduction band. So the gap can be called as a forbidden energy gap. A gap formed in between a valence band and conduction band is known as a forbidden energy gap. So here, so if you observe the valence band, the total energy of the valence band, so it is denoted with the symbol EV. So here the valence band energy we are going to denote with symbol EV, and the total energy of valence band is going to act upon upper surface here. Similarly, if you observe the conduction band energy it is denoted with symbol EC, and the total energy of the conduction band so is going to act upon lie upon towards the downward surface. So in this way, at 0 Kelvin temperature, if you observe, so this is the structure form. Similarly, this is the energy band form. So, similar if you observe, when the temperature is greater than 0 Kelvin, at this condition if you observe, so due to increase of the temperature, the electrons which are stick to the silicon atom, they are going to absorb the increased energy, and once they absorb sufficient amount of energy, so they are going to become free electrons. Once they become free electrons, So they are going to leave that particular position and move towards the nearby connection level. So for example, let's say that this electron is going to become free electron, and after that, it's going to move to the next energy level. So where the electron goes, there the vacant position is going to form. In the place of getting enter, automatically the holes are going to get generated. So in this way, due to increasing the temperature, so some of the electrons are going to leave the particular energy level and move to the next nearby energy levels. The same thing if you observe the energy band wise. So here, in the majority number of electrons will be lying in the balanced band. So due to increase of the temperature, the electrons which are in the balanced band, so they are going to leave the particular energy level band and they are going to move into the conduction band. So the place where the electrons are going to move, there occurs a vacant position is going to form. In the place of vacancy, automatically the holes are going to get generated. So in an intrinsic semiconductor, the number of electrons moving from valence band to conduction band and the number of holes generated in the valence band both will be equal. So here, let n be the number of electrons which are moved into the conduction band. Let us consider let p be the number of holes generated in the valence band. So here, both will be equal in shape. The number of electrons moved in the conduction band, number of holes generated in the valence band, both will be equal. So both will be equal only in the case of intrinsic semiconductor. So that's why let's consider for an intrinsic semiconductor we are going to denote with the symbol K. So in an intrinsic semiconductor, the number of holes which are in the conduction band and the number of holes which are in the valence band both will be equal. So this is a brief explanation about the intrinsic semiconductor before 0 and after 0. Okay.